Hello guys, welcome on Tesla Adventures. In this video, we'll going to discuss the complete paper of NSEP 2022, which was held on 27th of November 2022. So I would be sharing the answer key at the end of this video also, and we'll discuss the complete solution of each question. So there are 60 questions in this paper, and starting from the first one, and in this section A1, it is given that each question has only a single correct choice. So the first question is says that S is equal to distance traveled by a body in a straight line is equal to S square is equal to AT square plus 2BT plus C. So we have to find out the relationship of acceleration with S. So we know that 2S into ds by dt is equal to 2AT plus BT, 2BT. So ds by dt is velocity. ds by dt is equal to AT plus B. In fact, this is B, 2B. So AT plus B divided by S. This is velocity. So for acceleration, d square S by dt square. A will be equal to S into A. I am differentiating by U by V rule, minus AT plus B into ds by dt divided by S square. If I take out 1 by S cube common from this one, or we can take 1 by S square common, so it would be SA minus AT plus B into ds by dt, and ds by dt is AT plus B divided by S. So now you can take LCM and you can write it as 1 by S cube is S square A minus AT plus B whole square. Now you can substitute the value of S square, which is AT square plus 2BT plus C into A, minus you can open the square. It is A square T square plus B square or plus 2ATB. Okay. Now you can see that this is A, which is 1 by S cube, and this would be A square T square plus 2ABT, A square T square plus 2ABT plus CA, and minus A square T square minus 2ABT plus B minus B square. So these terms would be cancelled out, and A will be equal to CA minus B square by S cube. So you can see that acceleration is inversely proportional to S cube. So the correct option will be option number D. Now we move on the next question. In this question, you can see that there are two balls. The ball A has a mass of m1 and ball B has a mass of m2. Now ball A is moving with a velocity of v, and it strikes ball B, which is at rest, and the collision is elastic. Now these balls fly apart symmetrically at an angle of theta degree each with the initial direction of motion of ball A. So we have to find out the ratio of m1 and m2. So you can see that this is a oblique collision and therefore these balls are flying apart at some angle, and this is the line of impact. So the ball B was initially at rest, so it would be moving along the line of impact. So I have taken this direction. I can draw this on this line also. This is same thing. So let us first of all see that the initial momentum in y direction was 0, and therefore the final momentum in y will also be 0. So the final momentum in y will be m1 v1 sine theta and minus m2 v2 sine theta, and that would be 0. So I can equate these two. Cancelling this sine theta, you can see that m1 by m2 is equal to v2 by v1. This is the first equation. Now let us balance the momentum along x-axis. So you can see that m1v is equal to m1 v1 cos theta plus m2 v2 cos theta. Now we know that m1 v1 and m2 v2 are equal. So m1 v is equal to this is twice of m1 v1 cos theta. So cancelling this m1 with m1, v1 is equal to v upon 2 cos theta. Equation number 2. Now let us apply the definition of E. And E is 1 because collision elastic. And we know that the definition of E is only valid along line of impact. And this is the line of impact. So E is the relative velocity after collision upon the relative velocity before collision on the line of impact. So after collision, the relative velocity of these balls would be, you can see that along the component of velocity of A along this line of impact is v1 cos 2 theta. So I can write the relative velocity as v2 minus v1 cos 2 theta divided by the initial relative velocity, so along line of impact. So the component of this velocity along this line of impact will be equal to v cos theta. So this is v cos theta. So you can see that v2 minus v1 cos 2 theta is equal to v cos theta. We have already calculated the value of v1 and we can substitute the value of v1 here. So v2 will be equal to v cos theta plus v1, which is v by 2 cos theta into cos 2 theta. I have substituted the value of v1 here. Okay. Now we have to find out the value of v2 by v1. So you can see that in fact we have to find out m1 by m2. So m1 by m2 is v2 by v1. So m1 upon m2 is v2 upon v1, whereas v2 is this one. So you can see that this is v is common, and if I take the LCM, then it would be cos square theta plus cos 2 theta by 2 divided by cos theta. This is v2, and v1 is v upon 2 cos theta. So divided by v upon 2 cos theta. So you can see that if I take LCM, and I am taking this 2 also in LCM, so it would be 2, and you can cancel out this with this, v with v. So it is m1 by m2 is equal to 2 cos square theta plus. Now you know that cos 2 theta is also equal to 2 cos square theta minus 1. Okay, so this is equal to in fact yeah, this is equal to 4 cos square theta minus 1, and 1 can be written as cos square theta plus sine square theta. So it would be like that. So it is 3 cos square theta minus sine square theta, and out of this you can write it down as cos square theta, 2 cos square theta plus cos square theta minus sine square theta is cos 2 theta. Now you can substitute that 2 cos square theta is equal to cos 2 theta plus 1. We know this identity. So you can substitute this value here and it would be, finally I am writing it with red color. So it would be 2 cos 2 theta plus 1 if I substitute this value here. So final answer will be 2 cos 2 theta plus 1. So the correct option will be option number C. Now we move on the next question. In this question, you can see that there is a solid cylinder of mass m and it is rolling without slipping on this rough surface. A force F is acting on the cylinder in such a way such that the line of action of this force is passing through the center of mass of the cylinder. So we have to choose the correct option. So we know that obviously this cylinder, the torque of this force is 0. So torque of this force is 0, but this cylinder will be rotating with some angular acceleration and it would have some linear acceleration also. So we can say that this angular acceleration is due to the torque of friction which would be acting in backward direction. So we can conclude that the friction would be acting in backward direction and therefore it would be creating a torque which is clockwise, which is in clockwise sense, like that. So we can say that the acceleration of this system would not be equal to F by m alone, and therefore option number A is incorrect. Now the friction force is acting on the cylinder in the forward direction is also incorrect. And now we have to find out the magnitude of frictional force. For that we can write down both the equations of force and torque. So the net force is F minus F is equal to ma, and the torque equation is F into R is equal to I alpha. For solid cylinder, I is mr square by 2 and alpha is a by r. So cancelling this r with r, F is equal to ma by 2. So if I substitute this value here, so F minus ma by 2 is ma and F is equal to 3 by 2 ma. And this friction will be equal to ma by 2. So ma by 2 is equal to F by 3. So the magnitude of frictional force is F by 3. So the correct option is option number C. Now we move on the next question. In this question, you can see that there is a motor pump which is used to deliver water at a certain rate R from a given pipe. Now this rate R means the rate of volume flow. Now we have to obtain thrice amount of water from the same pipe in the same time, which means that we have to triple the volume rate flow, and for that we need to increase the power of the motor. So we have to find out the number of times the power of the motor has to be increased to fulfill our purpose. So we know that the power of the motor is force F dot V, and F can be written as dm by dt, the rate at which mass is delivered, into velocity. So power can be written as dm by dt into v square. Now dm can be written as rho dv, and dv is the volume, and volume of water flowing through this pipe of cross section area A can be written as a dx, elemental volume. So power is rho a dx by dt into v square. So dx by dt is also equal to velocity. So power is rho a v cube. Now we know that the volume rate flow R is area into velocity. And we have to use the same pipe, which means the area of cross section will remain the same. So to make this R thrice, we have to thrice the velocity, and therefore the power is proportional to cube of velocity. So if we are tripling the velocity, then the power would be proportional to 3 to the power 3, which is 27. So power has to be increased by 27 times. So the correct option will be option number C. Now we move on the next question. In this question, you can see that there are two solid balls of same material, but their masses are different. So obviously their volumes will be different. So let us suppose that there are two balls, and obviously if the masses are m and 8m, then the volume of the bigger ball would be 8v. So its mass is 8m and its volume is 8v. And therefore, if the volume is thrice of the smaller one, then we can say that the radius of the ball will be twice 2r, and the radius of this ball will be r. Because volume is proportional to r cube and volume is 8 times, so radius would be twice. So these balls are tied with a thread like that, and they are dropped from a balloon which is moving in the air in the upward direction. Now thread is weightless, and we have to find out the tension in this thread when these balls have attained steady state. Now the complete idea of this question is hiding behind this word, which is steady state. Because if we ignore this word, then we'll not consider the buoyancy and the viscous force acting on the balls, and we'll consider this as a simple problem of Newton's laws. And due to that, we will be concluding that the acceleration of these balls will be same, and that acceleration will be only due to the gravity, and therefore the tension in the thread will be zero. But this is not the case, because the steady state word has changed the scenario of the question. So in this case, there would be buoyancy acting on the balls, and I can say that due to the fact that the volume of this ball is v, so buoyancy acting on this ball is beta, and the volume of this bigger ball is 8v, so the buoyancy acting on this bigger ball would be 8 times of beta. The mg of this ball will be mg, and mg of this ball will be 8 mg. And we know that the viscous force is 6 pi neta rv, where v is the velocity. So we are considering the fact that velocity will be same, obviously, because then only the thread will be under some tension. And obviously if the velocity has to be greater, then the velocity of this ball will be greater. And if this ball has a greater velocity, then this thread will break. So this is not the case, and if you are thinking that the tension can be zero also, if the velocity of this ball is greater, so the velocity of this ball cannot be greater than this ball, because the viscous force acting on this ball is F, let's suppose, then the viscous force acting on this ball will be 2F. So you can see that the net force acting on this ball is greater in the downward direction. If the velocity of any ball is greater, then that ball would be the second one. So this cannot happen because rope will not break. So we have to consider the fact that velocity of these balls will be same. And therefore, this viscous force will be depending only on r. So the radius of this ball is r. So I have assumed that a viscous force F is acting on this ball in the upward direction. and the radius of this ball is 2r, so we can say that viscous force of twice magnitude is acting on this ball in the upward direction. Now, now as this system has achieved steady state, so we can say that the net force acting on this system will be 0. So our total force of 9 mg is acting in the downward direction, 8 mg and 9 mg, and a force of 3f is the total viscous, plus 9 buoyancy is acting in the upward direction. And in steady state V is constant, therefore I have assumed that the force will be 0. Now you can see that this F plus thrice of buoyancy is equal to 3 mg. First equation. Now if we find out the tension, so let us, we have not considered the tension in this equation, because this equation is for complete system and the tension acting in the system is internal force. So if I assume that the tension acting on this ball is in downward direction and the tension acting on this ball is in upward direction, so I can say that the individual ball, this one A, has a net force 0, and therefore T plus mg is equal to F plus buoyancy. Buoyancy is acting on the upward direction. So you can see that T will be equal to F plus buoyancy minus mg, and F plus buoyancy from this equation is equal to, if we can add and subtract twice of buoyancy in this equation, so this will be thrice of buoyancy, and F plus 3 buoyancy is 3 mg. So this is 3 mg minus mg, and it would be added with, in fact we have to subtract one term, and this would be minus buoyancy, minus twice of buoyancy. So T will be equal to 2 mg minus twice of buoyancy. Now you can see that there is no option which is matching with this one. So we have to assume that buoyancy is 0. So assuming that buoyancy is 0, so tension we can say that it would be 2 mg. So the correct option will be option number A. Now we move on the next question. In this question, we have to find out the value of this one. So this is a logical question, and we can solve this question by only using dimensional analysis. We don't have to find any value. So you can see that we know that energy, electrostatic energy, is kq square by r. So k is, this is q square by 4 pi epsilon naught r. So we can say that the dimensions of q square by epsilon naught is equal to u into r. So dimension of energy into r is equal to dimensions of q square by epsilon naught. And we know that energy is also equal to hc by lambda. So dimensions of energy into lambda is equal to dimensions of hc. So you can see that energy, this is also energy and this is energy, this is radius and this is lambda. So the energy, the dimensions of u into r are equal to the dimensions of E into lambda. So therefore we can say that the dimensions of hc are equal to dimensions of E square by epsilon naught. So this quantity is dimensionless, and therefore the correct answer of this option will be, this question will be option number A. Now we move on the next question. In this question, you can see that there is a sound source of fixed frequency, and it is in unison, which is also the resonance, with an open organ pipe of length 30 centimeter, and it is also in resonance with a closed organ pipe of length 23 centimeter. Both has same diameter. Now this information of diameter is given for end correction, and we have to include the end correction in both of them. So both pipes are sounding in their first overtone. So if the velocity of sound is 340, then we have to find out the frequency of source. So we know, let's suppose that frequency of source is F. And for open organ pipe, first overtone frequency will be V by L. So V is 340 and L would be L plus twice of E, which is the end correction. And this again will be L in this case is 23. So you can substitute the value of 23 here plus 2E. Now for closed organ pipe, the first overtone frequency is 3V by 4L. So 3 into 340 by 4L, and L of this organ pipe will be equal to this is 30 in fact for this organ pipe open, and for closed it is 23. And we know that in a closed organ pipe the end correction is only E. So you can equate these two, and this is 30 plus 2E. So cancelling this, so it is 90 plus 6E is equal to, this one is 92 plus 4E. So 2E is equal to 2 and E is equal to 1. So F frequency is 340 upon 30 plus 2. So you can see that this F frequency will be 340 upon 32 into 10 raised to power 2, which is due to the fact that it is given in centimeters. So it is approximately 1062 Hertz. So the correct option will be option number B. Now we move on the next question. In this question, you can see that the solar constant for Earth is this one, 2 calorie per centimeter square per minute, and this angular diameter of the sun is half degree on the Earth. So we have to treat the sun as a ideal black body, and we have to estimate the temperature of the sun. Now you can see that we know that solar constant S will be 2 into 4.2 in joules, and per centimeter square then it would be 10 raised to power minus 4, and per minute, and 1 minute would be 60 seconds. So this is the solar constant, and this solar constant will be equal to we know that solar constant will be equal to power emitted by the sun divided by the area of this sphere. Now we have to assume that there is an imaginary sphere whose radius is this one r, and whose center is sun. So area of this imaginary sphere would be 4 pi d square. Okay, so this term is called as solar constant. Now we know that this solar constant is given as this one, and the power emitted by sun will be sigma E A t to the power 4, where E will be 1 because we are assuming the sun as an ideal black body. So this power will be sigma into area of surface of sun would be 4 pi d square by 4. Okay, and the temperature of sun is T to the power 4. So it is divided by 4 pi d square. So cancelling out this 4 pi with 4 pi, and we also know that this, first of all, let us write down the t to the power 4. So t to the power 4 will be equal to, this is 4.2 into 10 raised to power 4 divided by 60, and into d square divided by capital D square and divided by sigma, and into 4. So this is t to the power 4. Now we know that this capital, this is small d is r, which we have written as this one. So let us write it down as small d. So you can see that this angular diameter is given as half degree, which means that tan 1 by 4 degree is equal to d by 2 upon small d. This is d by 2 upon small d, and for small angles it is 1 by 4, and in radians it would be equal to 1 by 4 into pi by 180. So you can see that capital D by small d is equal to pi by 360. So you can substitute these value in this term and we can find out the value of t to the power 4. So the correct option would be option number A. Now we move on the next question. In this question, you can see that there is a concave mirror whose focal length f is equal to 20 centimeters. And the focal length of concave mirror is r by 2, where r is its radius of curvature. So r will be equal to 40. Now you can see that some liquid water is filled in this concave lens, and then object is kept at some distance from this system in such a way such that its image is formed at the same position. So we can see that this system will still behave like a mirror, and the lens which is formed due to water will have a focal length FL, and we can estimate FL by the formula. This is mu lens maker formula, which is mu minus 1 into 1 by r. So r is equal to 40. So you can see that 1 by FL will be equal to 1 by 120, and FL will be equal to 120. Okay, so this is the focal length of lens. Now we know that the equivalent focal length of the system will be 1 upon Fm minus 2 by Fl. We already discussed this formula. We have discussed this formula in geometrical optics. You can refer the combination of mirror and lens topic in the playlist. So you can see that this is 1 upon F equivalent, and it would be 1 upon Fm, where m is the focal length of the mirror used. So the focal length of mirror will be is given as 20. So you can see that it would be minus 20, and it is due to the fact that this mirror is concave mirror. Minus 2 by FL. So FL is 120, so it would be 2 by 120. So this is minus 1 by 20 minus 1 by 60. And it would be equal to minus of 3 plus, in fact, minus 1. So minus 1 by 15. So the equivalent focal length of the system would be minus 15, and therefore the distance d at which we can keep the object so that this image is formed at the same point, then this distance d would be equal to the radius of curvature of this mirror system, and therefore we can say that this radius of curvature will be equal to twice of f, which we have calculated. So the correct answer would be 30. Now we move on the next question. In this question, it is given that a sample of radioactive atoms are produced when atoms are irradiated by neutrons. So, some neutral atoms are kept, and those neutral atoms are bombarded with neutrons, and as a result of that, some radioactive atoms are produced at a constant rate of r. So, let us see that some radioactive atoms are produced at a constant rate of r. So, let us name the atoms as A. These atoms further decay with a decay constant of lambda, and we have to find out, let us assume that they decay into B. So we have to find out the number of atoms of A accumulated at time t. So let us assume that at t is equal to 0, the formation of A started, and therefore at some time t, the rate at which A is formed, dNA by dt. I'm talking about the growth rate. I'm not talking about the decay rate. So it would be R minus lambda Na. You can easily understand this equation that the rate at which these A are accumulated is will be the net rate at which A is growing. So it would be the rate at which A is being formed minus the rate at which A is decayed. And the decay rate of A would be lambda Na. So you can integrate these terms, and you can see that it would be dNA upon R minus Na will be equal to dt, and integration, the limit of Na will be 0 to Na, and limit of time will be 0 to t. So this is ln R minus lambda Na, and limit would be from 0 to Na, and this is t. So you can, this would also be divided by minus lambda integration term. So ln, this is R minus lambda Na upon R is equal to minus lambda t, and this is 1 minus lambda Na by R is equal to e to the power minus lambda t, and Na will be equal to R by lambda into 1 minus e to the power minus lambda t. So this is the value of Na at any time t. So the correct answer would be option number C. Now we move on the next question. In this question, you can see that there are 3 branches, and each branch has some capacitance, and the potentials of all these points, all these 3 points are given. We have to find out the potential at O. So we know that we have to apply nodal analysis in such questions. So let us assume that VO is highest, and therefore the charge will be flowing from VO away from VO. Okay, on all 3 directions. So the charge flown in this direction would be VO minus VB, which is 200 into C, because Q is equal to CV. So C2 is equal to, this is C2, C2 is 3, plus this is VO minus VD, VD is 400, and the capacitance connected in this branch is C3, so it would be 5 plus VO minus VA. VA is 300, and the capacitance connected is C1, which is 2. The sum of all these charges will be 0. Therefore, this is 3 VO minus 600 plus 5 VO minus 2000 plus 2 VO minus 600. It would be equal to 0. And you can see that this is 10 VO, and it is equal to 3200. This is 2000 plus 1200. So VO is equal to 320 volts. So the correct answer will be option number B. Now we move on the next question. In this question, you can see that there is a spring block system of this has a mass m and this has a spring constant k. An insect of negligible mass is sitting on this system, and there is a mirror which is inclined at an angle of 60 degree, you can see. So this insect along with block is performing simple harmonic motion along in the vertical direction, and we have to find out the maximum speed of the insect relative to its image. So we can first of all see that that if we assume that the velocity of this system is v at this instant, then the component of v perpendicular to the mirror would be v sine 60, and the component of v parallel to the mirror would be v cos 60. This is v cos 60. Okay, so if we see that the insect, let us see that the image of the insect would be moving in this direction with a speed of v cos 60, because along the mirror velocities are same, and the velocity of insect would be in opposite direction along the perpendicular of the mirror, and it would be equal to v sine 60. So v relative will be 2v sine 60, where 2 into v's maximum speed is a omega and sine 60 is root 3 by 2. So we know that root 3 into a and omega is under root k by m. Now you can see that the block has a mass of m, and this insect is having a negligible mass, so it would be omega would be under root k by m. So you can write it down, and you can rearrange the terms, and you can write it down as 3k by m. So the correct answer would be option number B. Now we move on the next question. In this question, you can see that there is a system of lenses. There are 3 lenses, and the focal length of the first lens is 10 centimeter, and the second lens has a focal length of minus 10 centimeter, and the third lens has a focal length of 20 centimeter. This distance between first and second lens is given as 5, and between second and third lens is 10. An object is placed at a distance of 30 centimeters from the first lens, and we have to find out the final image. So let us first of all write down for first lens. We know that v upon u is the magnification is equal to f upon f plus u, and v is the first image, so it would be u is minus 30 and f of the first lens is 10, and upon 10 and minus 30. So it is minus 300 upon minus 20, so it is 15. Now this 15 is the image for this one, second lens. Let us draw the ray diagram. So it would be like that. And you can see that 15 would be here. And you can see that for this lens, the focal length is minus 10. So this is the focus of this lens, and we have kept an object at a distance of f from this lens, so the image will be at infinity. So v2 will be infinity, and therefore the final image of this lens would be at a distance of its focal length, which is 20. So the value of v3 will be equal to 20 centimeters. Now we move on the next question. In this question, you can see that there is a point source of light which is kept at a depth of d below the water surface in a deep lake. And the refractive index of this water is mu, and we have to find out the fraction of light which will escape out of this lake. Now let us first of all see that why only some part of light will escape, because some part of the light would be reflected back due to TIR, like that. Okay, so we can say that the light which is escaping from this circle would be able to come out of the water. So let us first of all see that this circle will have this angle as alpha. Let's suppose it is alpha. This distance is d, and you can see that this angle is theta c, which is the critical angle. So alpha is equal to theta c, and theta c would be sine inverse mu, 1 by mu. Now you can see that the solid angle of complete sphere is 4 pi. Solid angle of complete sphere is 4 pi, and let us imagine that this source has a sphere around it, and the intensity of light which is escaping out of this sphere is I naught. So the I naught intensity is escaping out of an solid angle which is 4 pi. So we can use the unitary method, and we can say that out of this 4 pi solid angle, the intensity which is escaping is I naught. So the intensity escaping from one solid angle would be I naught by 4 pi, and by sigma, by omega, you can say it as omega, it would be I naught by 4 pi into omega. So this intensity escaping out would be I naught by 4 pi into omega is 2 pi 1 minus cos theta c. Okay, cancelling out this pi with pi, this 2 with 2. So the fraction of intensity escaping is I by I naught, and it would be equal to 1 by 2 1 minus cos theta. So if sin theta c is 1 by mu, then cos theta c would be under root 1 minus 1 by mu square. So it would be under root of 1 minus 1 by mu square. So you can say that the correct answer would be option number C. Now we move on the next question. In this question, you can see that there is a empty container whose bottom has an object O, and there is a lens which is placed at a height of 45 centimeter from the bottom of the container. The image of this object through lens is formed at a distance of 36 centimeter above the lens. Now this container is filled with water up to height 40 centimeters, and then this new image is formed at a distance of 60 centimeters. So we have to find out the refractive index of the liquid. Now first of all, let us find out the focal length of this lens, and we can use the formula in this condition, and we can say that V upon U is equal to F upon F plus U. So V is 36 and U is minus 45, and F is unknown, and F minus 45. So this is, so you can see that this 36F minus 36 into 45 is equal to minus 45F. So you can see that minus 45 and minus 36 is minus 81. So minus 81 F is equal to minus 36 into 45. So cancelling this minus with minus, this is 9 and this is 5, and F, this is 4 again. So F will be equal to 20. Now we see that if this beaker is filled with water, then the image of refraction image, because the light ray coming from this object would suffer refraction at this surface, and the refraction image of this object would be the object for lens, and refraction image would be slightly up. So this distance by which this refraction image will shift will be, if its refractive index is mu, then this distance will be 40 by mu. Okay, so the value of u for the lens would be 5 plus 40 by u, and value of v is 60. So 60 upon minus x, let's suppose this is x. So 60 upon minus x is equal to 20 upon 20 minus x. So you can see that this is 1200 minus 60x is equal to minus 20x. So 40x is equal to 1200 and x is equal to 30, and this 30 is 5 plus 40 by mu. So 40 by mu will be equal to, this is 25, and this is 8 and this is 5. So mu will be equal to 8 by 5, and 8 by 5 is 1.6. So the correct option will be option number D. Now we move on the next question. In this question, you can see that there is a germanium plate of plate area this. So let us first of all write down all the data. So the area of the plate is 2 into 10 raised to power minus 4. A potential difference of 5 volt is applied on this plate. Its thickness is 1.2 into 10 raised to power minus 3, and the concentration of carriers is 1.6 into 10 raised to power 6, and the mobility of electrons is 0.4 and mobility of holes is 0.2. So the current produced in the germanium, I. So I is the current produced, and it is NEA, and Vd is the drift velocity, which is mu into E. So this is mu H plus mu E into electric field. So the value of N is 1.6 into 10 raised to power 6, and the value of this E is the electronic charge. So electronic charge has a value which is 1.6 into 10 raised to power minus 19, and the value of this mu is 0.4 plus 0.2, and electric field will be E will be delta V upon thickness. So you can see that delta V is given as 5 and thickness is given as 1.2 into 10 raised to power minus 3. So the value of I will be equal to 1.6 into 1.6 into 10 raised to power, this is minus 13 into 0.6 into E, which is V by D, this is 5 upon 1.2 into 10 raised to power minus 3. So the value of I from this will be option number A. So it would be 1.28 into 10 raised to power minus 13 amperes. Now we move on the next question. In this question, it is given that one fission of uranium nucleus releases 200 MeV of energy, and the minimum amount of energy required to run 1,000 megawatt of reactor for 1 year, assuming that efficiency of reactor is 30%. Now this efficiency is output power upon input power, and it is 30%, which means it is 0.3. So you can see that the input power required to run this reactor is output power upon 3 into 10. Okay. So for now the output power is already given as 10 to the power 9. You can see this is mega, and this is 10 by 3, so it is 1 by 3 into 10 raised to power 10. This should be the input power supplied by the fission of nucleus, fission of uranium. So in 1 year, if we estimate the total energy required, then it would be power into time. So power is 1 by 3 into 10 raised to power 10, and the total time in seconds in 1 year is 365 into 24 into 3600. So this is the total time in 1 year in seconds, and this energy is total energy is required. So we know that the number of uranium nucleus required would be the total energy E, which is this one, divided by the energy released by a single fission. So let us say that this energy is E. So this. So it is this is 8 into 365 into 36 into 10 raised to power 12. You can see that this is 10 raised to power 12. Divided by the energy released by one nucleus of uranium is 200 into 10 raised to power 6 into 1.6 into 10 raised to power minus 19. This energy should be in joules. So this is the number of uranium nucleus required. So the mass of uranium nucleus required would be N upon Avogadro number into molecular mass of uranium, which is 235. So this is the M, and this M would be in grams. This is grams. So by substituting these values, the correct answer would be option number B, which is 1.28 ton of uranium. Now we move on the next question. In this question, you can see that this is a Young's double slit experiment problem, and the value of a small d is given as 1 mm, which is equal to 10 raised to power minus 3. The wavelength of light used is 600 nanometer, which is 10 raised to power minus 9. And the value of d, which is the distance of screen from slits, is 1 meter. So we have to find out the minimum distance between two such points where the intensity on the screen is 3/4 of the maximum possible intensity, which is 75%. So let us see that we know that at center of the screen, central maxima is formed, and at a distance of y on the upper side of the screen and at a distance of y on the lower side of the screen, those 2 points are lying which has the intensity which is 3/4 of the maximum intensity. Now we know the formula that the resultant intensity is 4I0 cos square phi by 2, and this resultant intensity is the intensity at these points, so it should be 3/4 of peak intensity, which is 4I0. So this is 4I0 cos square phi by 2. So cancelling out this, cos square phi by 2 is equal to 3/4, and cos phi by 2 is equal to root 3/2. So phi by 2 will be equal to pi by 6 and phi will be equal to pi by 3. So at these 2 points, the phase difference between the waves is pi by 3, and therefore delta x will be lambda by 2 pi into pi by 3. So delta x will be, this is lambda by 6. The path difference between the waves at these 2 points. Now we know that the value of y is delta x capital D by small d. So delta x is lambda by 6. So 600 into 10 raised to power. Let us substitute the values. So it is 600 into 10 raised to power minus 9. Capital D is 1 and divided by 6, and small d is equal to 10 raised to power minus 3. So this y will be equal to 0.1 mm. So the value of the distance between these 2 points will be 2y. So the correct answer will be option number 2, which is 0.2 mm. Now we move on the next question. In this question, you can see that a ball is projected at some angle from the ground. It hits a wall, vertical wall, and this collision is perfectly elastic. And after rebouncing, this ball falls on the ground at a point which is directly below this point, which is at the maximum height. And the maximum height attained by the ball is also h. Now we know that this point is at a distance of r by 2 in the horizontal direction, where r is the range. And this x and this x would be equal because collision is elastic. So E would be 1. And this total distance would be r by 2. So you can see that x is equal to r by 4. So if we write down the coordinates of this point with respect to origin, which is the point of projection, so we can write down the coordinates of this point as 3r by 4 is the x coordinate, and this is the y coordinate, y. So we know a formula that y is equal to x tan theta into 1 minus x by r. This is the equation of trajectory in terms of range. So y is equal to, this is x, which is equal to 3r by 4, and this is tan theta, and 1 minus this x is 3r by 4 divided by r. So y will be equal to 3r by 4 tan theta into, this is 1 by 4. So y is equal to 3r by 16 tan theta. Now this r is the range. So we know that y is 3 by 16 and the value of range is u square sine theta cos theta into 2 divided by g, and there is a tan theta term also. So you can see that cos theta would be cancelled out and y will be 3 by 8 times of u square, this is u square sine square theta by g, and we know that this is equal to 2h. So y will be equal to 3 by 4 of h. So the correct option will be option number A. Now we move on the next question. In this question, there is a block which is projected with a velocity of 2v0 like that, and this rough surface has a constant coefficient of friction in such a way such that this block hits the wall B with velocity v0. So we can say that the change in kinetic energy of the block, which is half into m into 2v0 square minus half m into v0 square, is equal to work done against friction, and work done against friction would be mu mg into d. So this is half m into 3 v naught square, and that is equal to mu mg d. So you can see that v naught square is equal to 2 by 3 of mu gd. First equation. Now in the second part it is given that with what velocity the same mass should be projected so that it hits the wall B with the same velocity. If the surface is now moving upward with a acceleration of 4g. So if the surface is moving upward with the acceleration of 4g, then we can say that the normal reaction acting on the block N would be mg plus 4 mg. So N would be 5 mg. So now the new equation would be half m v square minus v naught square, and that should be equal to work done against friction, that is 5 mu mg d. Now we know that mu mgd, mu gd in fact is equal to 3 by 2 v naught square. So v naught, this is half v square minus v naught square is equal to 5 into 3 by 2 v naught square. Cancelling this 2 with 2. So it is v naught square minus v square minus v naught square is equal to 15 v naught square, and v square is equal to 16 v naught square. Therefore v is equal to 4 v naught. So the correct option is option number C. Now we move on the next question. In this question you can see that there is a sphere whose volume charge density is variable, and its volume charge density rho is equal to kr, where k is some constant. Let's suppose it is cr, where c is some constant. It is given in the question that rho is proportional to r, where r is the distance from the center. Now we have to find out the variation of electric field with the distance r. So for that, let us assume a sphere, elemental sphere, like that, whose width is, let's suppose, dx, and whose radius is x. Obviously I know that this x is equal to r, but for an instant I am assuming this radius to be x and this thickness to be dx. Now I wish to find out the q inside, which is the charge inside this sphere of radius r. So q inside will be equal to integration of rho dv, where rho is equal to cr and dv is 4 pi r square dr, and the limit of r would be from 0 to small r, because we have to find out the charge enclosed in a sphere of radius small r. So this is 4 pi c, and this would be r to the power 4 by 4. Limit would be r to the power r2. In fact, you can see that it is 4 pi x square dx. So it would be, and this is also x. Okay, so this limit would be from 0 to r, and therefore you can say that it is pi r to the power 4 upon into c. This is q inside, and electric field inside this sphere at a distance of r will be k q inside upon R square. So E inside will be K, Q inside is 4, in fact, C into pi into R square. So you can see that electric field is proportional to R square. So this relationship is a parabola, and this parabola is opening towards upward direction, towards positive y-axis. And externally, outside this sphere, this electric field would be E outside will be K Q total. Q total is the total charge, which is constant, and divided by R square. So outside this graph would be hyperbola. So the correct answer will be option number D. Now we move on the next question. In this question, you can see that there are 4 capacitors. These are 4 capacitors. C1 has a value of 4 microfarad. C2 has a value of 1 microfarad. C3 has a value of 2 microfarad. And C4 has a value of 3 microfarad. Now initially this switch was open, and therefore you can say that even though some battery is connected, we can say that the charge on this plate and the charge on this plate will be 0. The total charge on these 2 plates. Because in series combination, if let's suppose the charge on this plate is plus Q and charge on this plate is minus Q, then these 2 plates are connected together and they are isolated from the surroundings. There is no other connection of these 2 plates with surrounding. So any charge appearing on this plate and any charge appearing on this plate would be in total 0. So let's suppose that if minus Q is appearing on this plate, then there would be a plus Q charge on this plate, because minus Q has flown from this to this plate, and therefore there would be a negative charge on this plate, minus Q. So you can always say that in series combination the total charge of these 2 plates should be 0. Now in parallel combination, so let's suppose that they are in parallel. Like that. Okay. And these are in parallel. Now switch is closed. So you can see that this is 4, this is 2, this is 1, and this is 3. So you can see that 4 and 2 in parallel would be equal to 6, and 1 and 3 in parallel would be equal to 4. And we have to apply a potential of 15 volts. Now we can apply the voltage divider rule in series combination, and we can say that this is 6 and 4, this is 6 and 4. So this is 4. So let us assume that this is V1 and this is V2. So by voltage divider rule, we can directly say that the ratio of these 2 capacitance is 6:4, which is C1 upon C2 is 3 by 2. And if we sum up these ratio terms, then it is 5, and if we divide this 15 in 5 equal parts, then each part would be 3 volt. So what I am doing, that I am summing up these 2 and it is 5, and I am dividing this total voltage into 5 equal parts. So it is one part would be 15 by 5, that is 3. Now I can say that in series combination Q is equal to CV, and Q is constant in series. So C is inversely, or V is inversely proportional to C. So the capacitance, the value of voltage on first one will be in the ratio of will be in the reverse ratio of these two. So you can say that V1 would be 3 parts. 3 parts is 3 into 3, which is 9 volt, and V2 will be 2 parts. In fact, V1 would be in reverse ratio. So V1 would be 2 parts. So this is 2 into 3. This is 6 volt. And V2 will be 3 parts. This is 3 into 3, which is 9 volt. Okay. So these are the voltages on these two capacitance. So we can again redraw the diagram. And we can say that this was the diagram. And here we are connecting a battery. Okay. Now we can say that this was 4, 1, 2, 3. This is 4, this is 1, this is 2, this is 3. And we can say that these voltages V1 is 6 volt and these are 9 volt. And in parallel combination, voltage would be same. So the charge appearing on this capacitance is Q1 and this is minus Q1. And this is Q2 and this is minus Q2. So Q1 will be CV, 4 into 6 microfarad, which is 24 microfarad. And Q2 will be 1 into 9, which is 9 microfarad. Okay, so you can see that the sum of these two plates, sum of charges Q total, is 24 minus 9, which is 15 microfarad. So we have already discussed that initially the sum was 0, and after closing this switch, this sum is 15 microfarad. So we can say that charge has flown from D to C because the charge of this system has increased. So charge would have been flown from D to C. So Q flown will be 15 microfarad from D to C. So the correct answer will be option number A. Okay, so this is the correct option number A. And you can again, it is being asked that find the amount of charge that flows. So the amount of charge that has flown is this one, and you can see that this charge minus Q1 was this one, and this plus Q2 was this one. So we can write down that the Q total which has flown would be minus Q1. This is minus Q1 plus Q2. So minus Q1 is this and plus Q2 is this. So this is minus Q1 plus Q2 and this is minus 15. So minus 15 is flowing from D to C and therefore 15 is flowing from C to D. So the correct option will be option number A. Now we move on the next question. In this question you can see that this is a pulley system and the masses are given as shown. So let us first of all assume the tension T, and let us see that if the acceleration of this complete system in x-axis is a1 and the acceleration of this mass in the downward direction is a2. So we can easily find out the relation between a1 and a2 by using constraint motion relationship. So we are using summation t dot a 0. So you can see that on this complete system 2t tension is applicable in x-axis. So 2t into a1, and on this block alone t tension is applicable in y-axis. So it is moving in downward direction and t is acting in upward direction. So it would be a minus t into a2, and that would be 0. So 2a1 will be equal to a2. This is the first equation. Now you can write down the equation of motion and forces. So you can see that on this block, I can write down the equation that mg is acting in the downward direction. There is no friction and tension is acting in the upward direction, and therefore mg minus t will be equal to ma2. And on this complete system, you can see that this complete system is moving towards right hand side with an acceleration of a1. So you can see that 2t minus 0, because no force is acting in the backward direction, and this will be equal to m plus m into a1. Okay, so now if we further simplify this equation, and if we multiply this equation 1 with a factor of 2, and if we add up these equations, then we can say that 1 into 2 plus 2, equation 2. Okay, so 2mg and 2t would be cancelled out, will be equal to 2ma2 plus ma1 plus ma1. And we know that a2 is equal to 2a1. So 2mg is equal to 4ma1 plus ma1 plus ma1. Okay, so a1 will be equal to 2mg upon 5m plus m. Now m is 1 kg, so it is 20, and this is 5m is 5 and m is 15, so this would be 20. So this is 1. So the value of a1 is 1 and the value of a2 is equal to 2. So now we need to find out that what time will this block take to hit the base by moving a distance of 4 meters. So we can say that S is equal to ut plus half t square. S is 4 and that is equal to u. U is 0, half A is 2 and t square. So t will be 2 seconds. So the correct answer will be option number C. Now we move on the next question. In this question, you can see that there are n number of identical balls, each of mass m and radius r. They are in form of a bead, and these beads are stringed on a horizontal thread. This thread is being pulled and it is attached to two rigid supports, and the distance between these two rigid supports is L. And it is given that R upon L is small, but it is not negligible. The collision between these balls and the supports is elastic, perfectly elastic. And one of the ball is being given some velocity v. So we have to find out the average force which is applied by the balls on this support in a long period of time. So let us first of all see that each collision is elastic collision and each ball has the same mass m. So if any one ball is given some velocity v, then the other ball will also move after collision with velocity v, and the previous ball would come to rest. So in similar way, the ball which would hit the support is also moving with velocity v just before the hitting, and therefore after hitting the support it would be rebounding back with velocity v. So we can say that the change in momentum of any one ball when it hits the support is 2 mv, and the time taken in this change would be the time in which that ball will again hit this support like that. So this ball hit the support for the first time and it rebounds back, and then this momentum is being transferred in the backward direction. Then this ball hits this support and it rebounds back, and this momentum is being transferred in this direction again. So this is the complete time. So the time taken by the momentum to shift. So first of all, let us see that the change in momentum is 2 mv, and let us see that the distance between the centers of the ball is x. So when these ball would collide, then the distance between the centers of the ball would be x minus 2r. So the ball 1 has moved by a distance of x minus 2r before collision. So for n balls, the total distance moved is nx minus 2nr, and we know that this nx is L, which is the total length of the thread. So the total distance moved is L minus 2nr. Now we see that the time taken to move this distance would be L minus 2nr divided by v, where v is the speed, and this is the time of single side journey, but we have to take the time of complete cycle, which is this one. So the total time taken would be twice of L minus 2nr divided by v, and therefore the force acting on the ball on the wall will be change in momentum, which is 2 mv, upon total time taken, which is twice of L minus 2nr by v. So cancelling this 2 with 2, this is mv square by L minus 2nr. So the correct answer would be option number B. Now we move on the next question. In this question, you can see that there is a cylindrical tumbler of diameter d, and the walls of the tumbler and the sides of the tumbler are smooth. Now there is a thin rod of length L, and this rod is balanced on the edge of the tumbler as shown in the figure. This angle is alpha, which this rod is making with horizontal, and we have to find out the value of alpha so that this trick works. I have already drawn the direction of forces, and I have already drawn the FBD of this figure. These forces are not represented in the question, but these are drawn by me already to save the time. So we can see that this mg would be acting in the downward direction, this n would be acting like that perpendicular to the rod, and this n2 will be acting perpendicular to the contact, which is wall. Now you can see that the net force acting on this system in x-axis and as well as in y-axis is 0. So we can balance out the net force in x-axis, and we can say that this n2 is equal to, you can see that n2 is equal to n1 sine alpha. This is the component of n1. So this component of n1 would be n1 sine alpha. So n2 would be equal to n1 sine alpha. This is first equation. Now if we balance out the forces in y direction, then n1 cos alpha will be equal to mg. Okay. So you can see that this is the second equation. Now we can find out the torque about any point. So let us find out the torque about this point n2. Okay, so let us find out the torque about this point A. So torque about A would be 0 because this rod is not rotating about any of the axes. So therefore we can say that the torque of n2 will be 0 because n2 is passing through the point A. So n2 into 0, and the torque of mg would be mg into this distance. So this would be L by 2. This is the length of the rod, which is L by 2 cos alpha. So this is plus mg into L by 2 cos alpha, and this distance. So let us suppose that this distance is small l. So we can write down the torque of N1 as minus of, because mg is rotating this rod about A in the anti-clockwise sense, while N1 is rotating this rod about A in the clockwise sense. So we can write down the torque of N1 as N1 into L, and the net torque would be 0. Now we know that this small l cos alpha is equal to d. So small l is equal to d sec alpha. So we can say that mg into L by 2 cos alpha is equal to N1 into d sec alpha. So this is the first relation, and we already know that N1 is equal to mg sec alpha from this relation. So this is mg L by 2 cos alpha is equal to, this is mg d and sec square alpha. So cancelling out this mg with mg, so we can see that cos cube alpha is equal to 2d by L, and therefore cos alpha will be equal to 2d by L to the power 1 by 3. So the correct answer would be option number B. Now we move on the next question. In this question, you can see that there is a rod AB which is uniform rod and its length is 2L. One of its end A is in 100 degree boiling water maintained at constant 100 degree Celsius temperature, and the other end B is in the constant temperature of melting ice, which is 0 degree Celsius. Now we have connected. Now first of all, let us analyze this single rod AB. So we can see that this rod AB, this length is equal to this is L by 2 and this is L by 2, and this length is equal to L. So you can write down the resistance of AP as L by 2 Ka, and let us suppose that this is R by 2. So resistance of QB is also L by 2 Ka, so it is also R by 2. The resistance of PQ is equal to L by Ka, which is equal to R. Okay, so this is a combination of three resistances. It is R by 2, this is R, and this is R by 2. And the temperature difference between the two ends is 100 degrees Celsius. Now we have connected another rod of same material, same cross section, but its length is 3L by 2. So you can see that the resistance of this rod, this one, so let us name it as R dash. So R dash is equal to 3L by 2 Ka, this complete rod. Okay, so this is R dash, and R dash is therefore equal to 3R by 2. So I can connect a resistance of 3R by 2 here. So you can see that in this case, this is 3R by 2, this is R by 2, and this is R by 2. So previously, when we have not connected this resistance, then this potential difference between P and Q can be easily calculated, and you can see that the temperature difference, this total temperature difference is 100, and this temperature difference would be equally divided into R and these two R by 2s. So this temperature difference would be 50 degrees Celsius. Now when we are connecting another resistance which is 3R by 2 in the parallel to this one, then you can see that the value of this resistance is decreasing as we have shunted this resistance with another resistance. Therefore we can say that this temperature difference delta T would be slightly less than 50 degrees Celsius because the total temperature difference is still 100 degrees Celsius and we have decreased this resistance. So the potential difference, or we can say the temperature difference across this resistance would be now less than 50 degrees Celsius. So we can also say that if Tp minus Tq is 50 and now Tp minus Tq is less than 50, so we can say that the temperature of P would have been decreased or the temperature of Q would have been increased. So the option number 1, which says that temperature at P will increase and temperature at Q will decrease, is the incorrect option. Now the second option, which says that the rate of flow of heat will be increased by 25%. So the rate of flow of heat is the thermal current. So let us write down the thermal current as 100 upon the equivalent resistance initially, which was 2R. Now you can see that the new thermal resistance would be 100 upon the new equivalent resistance. So you can see that the equivalent of 3R by 2 and R in the parallel would be 3R by 5, and 3R by 5 and R by 2 and R by 2 are in series. So you can see that 3R by 5 and R is in series, and therefore it is 8R by 5. So the new current would be 8R by 5, 100 upon 8R by 5. So this current was equal to 50 by R, and this is equal to, this is 25 and this is 2. So this is 125 by 2. So you can see that 125 by 2 is equal to 67.5, and 67.5 is, if we see that the current initially was 50 by R and now it is 67.5 into R. In fact, sorry, 62.5, it was 62.5. So you can see that the increment in this current is 12.5, and 12.5 is the increment of 25%, because 25% of 50 is 12.5. So the correct answer is option number B. So option number C is also incorrect, and option number D is also incorrect. Now we move on the next question. In this question you can see that there are two masses. One of them is 2m and the other one is m. The distance between these two masses is equal to 3 astronomical units, which is d, 3 AU. So we can find out the center of mass, and it would be equal to, this would be at a distance of 1 AU from 2m, and it would be at a distance of 2 AU from m. Now they are revolving around their common center of mass with a period of 2 years. So you can see that the force acting on any one of them, let us see that this is the force of attractional force, and this is the centrifugal force, which is mv square by r, or mr omega square. So F is equal to G into M into 2M by 3. I am taking AU as 1. So 3 square, and it is equal to M, and R is, for this mass, R is 2 AU. So this is 2 into omega square. So cancelling out this M with M, you can see that this is 2 GM by 9 is equal to 2 omega square, and the time period is given as 2 years. So Gm divided by 9 is equal to 2 pi by 2, and I'm taking the standard unit of time as years. So you can see that it would be Gm would be equal to 9 pi square. This is the equation number 1. Now we can see that the 1 AU is the distance between Sun and Earth, and the time period of Earth's rotation around the Sun is 1 year. So we can say that for Earth and Sun system, G m of Sun into m of Earth divided by 1 square is equal to m of Earth into r is again 1, and this is omega square. So this is Gms is equal to omega, which is 2 pi by 1 whole square. So you can see that if we equate the value of pi square, so Gms by 4 is equal to pi square. So Gm, this is Gm, but is equal to 9 pi square is Gms by 4. So cancelling out this G with G, so you can see that m is equal to 9 by 4 ms. So 9 by 4 is 1.25. In fact, it is 2.15. In fact, 2.25. So the correct answer would be option number A. Now we move on the next question. In this question, you can see that there is a rod of mass m which is bent into this 4 semicircles like that. And for this rod, we have to find out the moment of inertia about an axis which is passing through A and perpendicular to this plane which is coming out towards the observer, which are us. So let us first of all find out this with the shortest possible method, and for that we are using perpendicular axis theorem. So we know that along this axis, if we draw a semicircle, then along this axis of the semicircle, the formula of moment of inertia is same as that of the bigger ring. So if this ring was complete, then the moment of inertia about this axis would be mr square by 2. So for this semi-ring, the formula would be same, which is mr square by 2. So we can say that for these 4 rings, the total moment of inertia about this axis, let us name it as AB. So AB, I along AB would be equal to 4 times of mr square by 2, where m is the mass of a single ring. So you can see that 4m is equal to m, so m is equal to m by 4. So this would be mr square by 2, I along AB. Okay, you can substitute the value of m as m by 4, and this is the result. Now along this axis, this one, which is passing through COM of the semi-ring, the moment of inertia is again the same, formula is same as for the complete ring, and it is mr square by 2 again. So we can see that for first ring, this is the first ring, the MOI along this axis, let us name as this as y-axis. So I along y-axis would be, this is mr square by 2. So we are writing it down for the complete 4 rings. So let us write down ICOM for the 4 rings, which is 4 times of mr square by 2. Okay. Now the distance, now we have to write the term mh square for each of the ring. So this is r, so we can write it down as mr square plus this distance is, this is r, and this is r. So this is 3r, so we can write it down as plus m into 3r whole square. This distance is r, and r, 5r. So So we can write down as m into 5r whole square. Similarly, for the last one, it would be r. This is r and r, 4r, 5r, 6r, 7r. So it is m into 7r whole square. Okay, so this is the moment of inertia of this complete ring, and it would be Iy would be equal to, this is 2mr square plus this is mr square plus this is 9mr square, this is 25mr square, and this is 49mr square. So you can see that 49 plus 3 is 52 and plus 9 is 61, and this is 61. In fact, this would be 61, yes, and 61 plus 25 would be equal to 86 mr square. So it would be Iy would be 86 mr square. Now we know that small m is m by 4, so it would be 86 by 4. So 86 by 4 mr square. So 86 by 4 is 43 by 2 mr square. So you can see that if we find out the moment of inertia about this axis, so the required moment of inertia would be the sum of IAB. So the moment of inertia about this axis plus Iy. So we have applied the perpendicular axis theorem, and therefore you can see that it would be 44 by 2 mr square, and this was 22 mr square. Okay, so the correct option would be option number C. Now we move on the next question. You can see that in this question there are 3 point charges which are placed at these coordinates on the x-axis. The first one is placed at x is equal to minus d. This is q. The second, minus 2q, is placed at origin, and third one, which is plus q again, is placed at x is equal to plus d. Now we have to find out the electric field at a point which is at a distance r, where r is very greater than d. So let us first of all write down the electric field due to this charge 1, this is 2, and this is 3. So this would be E1 because it would repel any positive charge at this point. This charge plus Q will again repel, and let us write it as E3, and this second charge would attract, so E2 would be in this direction. Now the net field would be E1 plus E3 minus E2, and we can write that the net field E would be E1 which is KQ by R minus D whole square, and plus E3 which is KQ by R plus D whole square, and minus E2 which is KQ, in fact 2Q by R square. So now you can take KQ common, and you can see that it is 1 upon R square minus D square whole square, and this would be R square 2 R square plus D square minus 2 by R square. Now you can take out this term R square common, and you can write it down as E is equal to this is KQ, in fact 2KQ by R square I am taking common. So this is KQ, 2KQ by R square, and this would be R square plus D square, and divided by this would be R square into 1 minus D square by R square whole square, and this is minus 1. So you can see that what I have done, that I have taken R square common, and it would be R to the power 4, and I have taken out this 1 upon R square here, and this is this. Now I am taking this term in the numerator and I am applying the binomial theorem. So E would be equal to 2kq by r square, and this would be 1 plus d square by r square. And after applying the binomial theorem, you can see that it would be 1 plus 2d square by r square and minus 1. So you can see that if I'll multiply 1 with 1, then it would be cancelled out with this 1. And if I multiply 1 with this term and this 1 with this term, then it would be 3d square by r square. And if I multiply this term and this term, then it would be 2d to the power 4 by r to the power 4. So we know that d is very less than r, so we can neglect that multiplied term. So finally I can say that it would be 2kq by r square, and here it would be 3d square by r square. So you can see that this is 2kq d square. 2kq d square is q. So this is q, and the total power of r is 4. So if I compare it with this term, then the value of a will be 3 and the value of n would be 4. So the correct answer would be option number C. Now we move on the next part. In this question, you can see that there is a cyclic process 1, 2, 3, 4, 1, and it is given that 1, 2 is isochoric process. Obviously you can see that 2, 3 is isobaric, and it is also given that T3 and T4 temperatures lie on the isotherm, which means that at this temperature T3 and this temperature T2 are equal. This is not a isothermal graph, but in some other isothermal graph, these two temperatures lie, which is indirectly stated that T3 and T4 are equal. So we have to find out the work done by the gas during this cycle. Now first of all, let us analyze this problem that the volume in this case is, this is V1, this is V4, let's suppose, this is V3, this pressure is P1 and this pressure is P2. So the area will be work done, and area would be half. This is trapezium, so the area of trapezium is half sum of parallel sides. So the sum of parallel sides would be V4 minus V1 plus V3 minus V1 multiplied with height, which is P2 minus P1. So this is the work done, and you can also write it down as half. This is V4 plus V3 minus 2V1 and into multiply by P2 minus P1. Now you can take common V1, so it would be V4 by V1 plus V3 by V1 minus 2, and this would be P2V1. So P2V1, you can see that P2V1 is nRT2, nRT2, and P1V1 is nRT1. So the work done will be equal to 1 by 2 nR T2 minus T1 multiplied by V4 by V1 plus V3 by V1 minus 2. So this would be the work done. Now we have to substitute the values of V4, V3, V1 in terms of temperature. So let us first of all write down all the relationships. First of all, let us write down the coordinates of the volume and pressure. So you can see that we can write it down as, on this line volume is constant. So we can say that P1 by T1 is equal to P2 by T2. So P1 by P2 is equal to T1 by T2. First equation. Now on this line you can see that pressure is constant. So we can say that V1 by T2 is equal to V3 by T3. This is second equation. Now you can also say that on these temperatures are equal, T3 is equal to T4. So I can say that P1, in fact P2 V3, P2 V3 by NR is T3 is equal to P1 V4 by NR. It is T4. So P2 by P1 is also equal to V4 by V3. Or we can write it down as P1 by P2 is equal to V3 by V4. So by equation 1, it is equal to T1 by T2. This is equation 3. So we have already, now we will see that V1 by, this is V3 by V1 is equal to T3 by T2. This is equation number 4. So we have already extracted the value of V3 by V1. This is the value, and you can you have to also find V4 by V1. So you can use these equations and you can eliminate V3. So you can eliminate V3 by dividing these equations. So 4 divided by 3. So when we divide 4 with 3, then it would be V4 by V1, and that would be equal to, this is this upon this, so that would be equal to T3 by T1. So you can substitute this value. So work done will be equal to half NR T2 minus T1 into V4 by V1. So V4 by V1 is T3 by T1, and this is plus V3 by V1, which is T3 by T2 minus 2. So you can see that the required relationship is this one, option number C, T3 by T1 and T3 by T2. This is T3 by T1 and this is T3 by T2 minus 2, and this is NR T2 minus T1. So this is half NR T2 minus T1. So the correct answer is option number C. Thank you.